It's my pleasure to be able to introduce Greenberg, well-known author and publisher. Over the years, he's written 23 books on toy train collecting. He was the pioneer, and he's a very well-educated man. Bruce is a graduate, with a Bachelor of Arts degree from Princeton University. When he graduated, he thought to himself, well, I want to become a lawyer. So he entered law school at George Washington University. But after the first year, Bruce decided that law wasn't really something that he wanted to pursue. He was more interested in politics. And so he attended the University of Michigan, and he received a degree, it was a PhD degree in political science from the University of Michigan. He then spent 3 years teaching at Knox College in Galesburg, Illinois. We all know Galesburg. It's a big rail town, and I guess that maybe kind of spawned his interest in trains while being there. After Knox College, he became a college administrator at Antioch College, and he moved to Columbia, Maryland. Years, and in 1991, Bruce sold his business, Greenberg Publishing, to Commonwealth Publishing. And here in the last few years, he's become more and more, he's gone back and he's self-publishing. He did a fantastic book on standard gauge trains, and he's going to be talking tonight about O-gauge trains, and it will be the first series from 1915 through 1928 on Lionel trains. He's in the process of writing the second book that will take the pre-war trains up to World War II. And he's working on that right now. So that's something to look forward to. It's my pleasure. Bruce has come, and his lovely wife have come all the way down to join us here tonight. I present Bruce Greenberg.
Thank you very much, Peter. Now, the motor story has basically several components. Obviously, the factory wants to build a motor at the lowest possible cost that's compatible with having something work. It also wants to have a motor that actually works and satisfies the consumer. Thirdly, quite as important, they want a motor that can be repaired. But then the motor has another role. Lionel was in a very, very competitive market in 1924. There was Ives, the new kid on the block door fan, American Flyer, Bing, and some others as well. And so Lionel was faced with competitive products every year. And what we're going to talk about tonight, in part, is how the motor changes were in part reflection of the competitive pressures that Lionel had from Ives and door fan. So I set the stage here, and let's see what happens when we push the button. In 1924, Lionel was still using the Type 4 motor. Now, the Type 4 motor has some interesting features I'll point out to you. The motor has two brushes. Nearly all electric motors of this kind have two brushes. A brush is a carbon or a carbon composite material that runs against what's called a commutator and then feeds electricity to the inside of the motor. The brush is critical. The brush must convey current reliably. This particular design has a phosphor bronze spring, a little strip of metal. It's no more than probably a little more than 1/8 of an inch, and it's about this long, It goes from here to here. And it's a spring. So it puts pressure against the commutator. It pushes the brush against the commutator, which is what you want. You want this brush pushing against the commutator, not floating free. Well, phosphor bronze is a very fine material. It's a spring material. It's inexpensive to manufacture and relatively reliable. Here I'm showing you the inside where the phosphor bronze strip ends in a brush which is encapsulated in a copper cap with a rivet in between. And there are two brushes here. Now, as students of motors, you know that motors get hot. And get very hot. And the brush commutator place is a place that gets very hot. Unfortunately, the phosphor bronze spring will lose its temper, lose its springiness if it gets too hot. And what happens then? Oh, heck. One unhappy boy. Yes, and the factory gets a return. The dad says, we won't buy any more of that kind. Now let's take a little detail here into Ives. As I said, Ives was Lionel's most important competitor, second largest company in the field. Or it may have been the largest, we're not sure in 24. But Ives did something in 1924 that changed the market, changed the experience of toy trains. They introduced for the first time a remote reverse. If you push the button, the train went to neutral. Push the button again, went to reverse. Push the button again, it went to neutral, and then back to forward. It was a brand new, wonderful feature. For the first time, a boy could control the train on the far side of the track. Now, you can see Ives said the sensation of the toy world. That was a fair statement. They weren't puffing. That was real. So we're going to come back to this and what happened with Ives. But in the meantime, I want to pick up my story about the phosphor bronze strip. The Lionel catalogs are wonderful to study. Lionel is the most accurate of the toy train companies in its rendition of what they're actually doing. That is not to say they're always accurate. In fact, we'll have one instance this evening I'll show you. But this 1925 catalog answered the question, when did the new motor start? And there it is, right in front of us. What we call the Type 5. And below it we see the Type 4. They were continuing both at the same time because the older trains in the line were still using the Type 4, but they were really proud of their Type 5. Why were they so proud of Type 5? The Type 5 motor design reduced operating problems because they replaced the phosphor bronze strip with just little steel springs. They're little steel springs, which were much less sensitive to heat and heat problem. It was a very clever solution. Not only did they do that, but these are much easier to replace. Have any of you ever tried to replace the brushes in a Type 4? What do you have to say? Thank you. Okay. And Type 5, what do you think about that?
Great.
I didn't pay them either. Okay, really nice engineering. I like this. And they also made a very nice form. I like rectangular forms. Rectangular on 3 sides and irregular on the 4th. So, it was a substantial improvement of motors.
Bruce, did they patent that?
I assume they did, but I have not. Great question. Maybe we'll look it up.
We'll do research.
Yes, well, we should do. Now, we've introduced the Type 5 motor. Lionel has a much improved motor. But now let's go back to the Ives story, because the Ives story will be part of the next version of Lionel motors. Ives, you can imagine, Lionel would have scouts who would visit the Ives showroom at Toy Fair in New York, and Ives would have scouts visiting a Lionel showroom. Can you imagine when the scouts came back in either January or early February 1924 and said, "Boss, we got a problem." "We got a problem." And Mr. Cowan said, "We have a problem." They recognized the tremendous advantage of that remote reverse. So I presume that Mr. Cowan told the engineering department, "Get it done." The problem was, of course, how do you do a double pole, double throw switch remotely operating? It's not, today it's no problem, but 1925, 26, it's a little more difficult. Lionel, in 1926, only 2 years, developed the pendulum reverse, a double pole, double throw switch, pendulum reverse for a standard gauge line. The standard gauge locomotive has lots of space underneath the hood. It was good solution. The problem was O gauge, where you go from this big to this big. How do you make this mechanism fit? And that was the challenge. Well, in 1927, Lionel proudly announced it had solved the problem. And here we are seeing in the 27 catalog the new type motor, and we're seeing the old motor, the Type 5 motor, and we're seeing the new Type 6. And you notice that it has a relatively flat line, horizontal line, as opposed to the hump. And here is the reverse mechanism fitted in between the two side frames. They made a picture. They claimed that they were going to build it this way. I have never seen this piece. If you ever see one at a reasonable price, you should say, "I need that," because it's a factory prototype that was never put into production.
So Lionel was never put into production.
Pardon?
The Lionel was
Never put that particular piece from the catalog.
Okay.
Now that's really interesting. Most of what appears in the catalog actually gets built. It looks like it, but it didn't look like that. Here's what it looked like. How many of you have ever seen this before? How many of you ever seen this motor like this? How many? Only one. That's really interesting. Okay. Well, I hadn't seen it either until I started working on the book. And when I first started taking apart trains to photograph at my friend Marty Margolis's house, I said, "Egad, it's cumbersome. It's not sleek and handsome. It's too much." So they couldn't fit the reverse mechanism in between the side frames as they showed in the previous drawing. But it worked, and it was in the line for a number of years.
And what was that called? What was that reverse?
It was called a pendulum reverse. Okay, we call it that. They simply gave it a part number. They probably called it remote reverse in the catalog. We call it pendulum reverse because it more or less looks like a pendulum. And we develop our own name for things to make it easy to remember. Now, they had the O-gauge motor without the pendulum reverse, the O-gauge motor with a little manual wafer switch you push, and both the motor with the pendulum and without, the brush side looks like this. Now this brush side is very interesting. It's different from that. Remember, here it goes all the way across, and here, I'll show you a better picture, the brush holder is held in by two tabs. The tab here and a tab here. But here, the tabs are gone away, and instead, the brush unit is pushed out from the side with spacers and takes up just a little less space in this area, the critical area, so that this thing can be put there. So they reworked the brush side to make it possible to put the pendulum unit in the motor. Again, I said, really neat engineering. When I looked at this, I said, these are really clever people figuring out how to do this in a cost-efficient way. So this is all driven by Ives, all driven by the Ives remote reverse to create a pendulum unit, to create an O-gauge special for the pendulum. The engineer continued to work. The engineering department was always saying, what can we do next? What reductions in cost, improvement in performance? So now we go to 1929, when the next major step in the Lionel O-gauge motor was introduced. Now I showed you a moment ago the brush side. This is a metal unit with a piece of insulating fiber, another piece of metal. It's a complicated piece of construction, and you have to be very careful you don't short out this into the frame. A new kind of material became available for electric motor engineers, phenolics. It's an early plastic consisting of fabric and resin pressed together. It's cheap to produce, and it doesn't conduct electricity. So here you no longer have the insulating problem of the brushes, the brush holders. So again, we see something that availing themselves of new materials in making toy trains. It was a brush plate was simpler to manufacture and less costly. Now we want to look at the other side of the Type 7 motor because some things are going to happen here. This is the Lionel gearing system. And I will talk about this thing. This is called a pinion gear. How many people have heard about pinion gears? Okay. It's very critical. It's fastened at the end of the armature shaft, and it's pressed on by a press fit. And then it drives either one or two gears. In this case, it's driving this gear and that gear. And then in the center of those big gears is a little gear. This combination of big gear, little gear on the same axle is called a compound gear. It works, it's efficient, reliable, but it has 5 parts. So Lionel has a pinion gear driving a compound gear. Now let's pick up the door fan story. I pointed out that in 1924, door fan was a new kid on the block, a really innovative toy train company. And in 1925, they had a very impressive product called the take-apart O-gauge locomotive. Boys and girls could take apart their toy train for the first time and actually get them back together. Now that is a wonderful idea. I've taken things apart, and oh heck, I couldn't get them back together. If I had a door fan train, I would have gotten it back together. Lionel Marketing saw this as a challenge. It's a really important new idea. How do we meet this challenge? What can we do to compete with the take apart? Now, at the same time, by the way, this is 1925, they're already working on the pendulum reverse. They have a full plate of engineering product, and have a new one they want to make. How do we create our competitor to the take apart train? Lionel in 1928, very fast, 3 years, offered a very new idea on how to build a motor. Quite different from the way that Dorfan pursued it. Again, both were very well done, but it's different. Lionel called it the GreenbergLionelO, and the design was available both for O gauge and standard gauge. Now, one aspect of this feeds into the motor story, the regular motor story. The GreenbergLionelO was used in special locomotive called GreenbergLionelO, which sold at a premium price over regular locomotive. They had extra features, and the sales were relatively modest. We know surviving pieces. Less surviving pieces, less successful sales. But there was a part of the GreenbergLionelO idea that really then transferred and became part of the ongoing Lionel regular motor story. And remember, we mentioned a few moments ago about that pinion gear. The locomotive motors had pinion gears at the end of armature shafts. The GreenbergLionelO motor had this great idea, great innovation. They made the hole on one side of the side frame large enough for that pinion gear to go out without having to be pulled, taken apart. Very clever, elegant simplicity. And here's an example to show what I'm talking about. This is actually an O-gauge GreenbergLionelO motor side frame. And by the way, this is pictured in the book. This is from a set that's in the original boxes, and as Lionel marketed it, they actually had latches holding the parts in the box. But the part we're most interested in is this hole. That's the hole they put in the side frame so the pinion gear could come through it. Of course, when you have the pinion gear come through it, what are you going to do with it? You're going to float up and down? You better not. You had to hold it in position. So they put a cover over it, and the cover was fastened into these two female receptacles. So we're going to have a cover over the pinion gear coming through. To support the motor shaft and pinion gear, Lionel designed a new gear support cover using the phenolic material. Oh, they used it on the brush side, now they're going to use it on the gear side. The first cover has a diamond shape. So if you have early 30s O-gauge locomotives, you can readily see that you can see the end of the diamond, and if you have a flashlight and look upside, you can really see the diamond shape. So this new method of supporting the pinion gear with the brush plate is really, again, ultimately derived from the GreenbergLionelO competition with Dorfan. But remember, I talked about the compound gears. So the pinion gear, which you can't see behind the phenolic, meshes with the big gear, little gear, little gear. There are 5 pieces here. 1, 2, 3. I better count. 1, 2, 3. There's 6 pieces here. Okay? I work on my math here this evening. And the engineer said, I wonder if we can do something to simplify the world. Oh, instead of two compound gears, we can have one big gear. 6 pieces get replaced by 2 pieces. Does that sound to you like cost cutting? And of course they changed the shape of the gear cover. Smaller gear cover, less material. A triangular gear cover. So this is the Type 9 motor about 1931. It's quite a, you can see why, when I studied these, I was so fascinated by taking them apart and seeing these changes, and then trying to figure out what happened. It was just great fun. Here's the other side of a Type 9 motor, continuing our phenolic brush plate. So now we're phenolic on both Type 9 and Type 8 on both sides. Now Ives again. The Ives story intersects Lionel again. Although the late 20s, mid-20s, were a period of enormous financial and commercial success in America, unfortunately, Ives did not share that success. The Ives management really was remiss in meeting the competitive market. And I can tell you more about that later. But in any case, Ives ended up in bankruptcy in 1928. And often in bankruptcy, who wants to buy it? The competitors, obviously. And so Lionel, with American Flyer and Hafner, won the bidding for the Ives estate, bankrupt estate, in 1928 in New Haven, Connecticut.
So they had a single bid together? It was a consortium?
Yeah. They conspired.
Yes.
They negotiated with each other. Obviously, Lionel had the largest investment. Unfortunately, the consortium managed to lose money in 28, lose more money in 1929. And so at that point, Lionel, probably reluctantly, acquired the assets or the interest of both Hafner and American Flyer. But then the original Ives license from Westinghouse for the remote reverse became Lionel property. They did not immediately do anything about it. But sometime, probably in 32, maybe late 31, 32, the Lionel engineers redesigned. They redesigned the Ives remote reverse, taking the basic concept, miniaturizing it, making it much more reliable and less costly to manufacture. It was a wonderful piece of engineering. In fact, the Lionel E unit was so well designed, it was still being used in the mid-1980s in new Lionel equipment.
Did American Flyer and Hafner get rights to that E unit?
No.
Did they have to develop a different one? Or what
Yes.
did they do?
American Flyer developed its own reverse unit, which was a much more complicated matter. Hafner was primarily mechanical trained. I don't know, I should remember, but I've forgotten whether Hafner ever manufactured electrical, I think it had some electric motors in some trains. But I doubt if they had a reverse unit, because they were the low end, they were the Marx competitor. Well, so in 1933, Lionel said, we're going to put the reverse unit, a wonderful new reverse unit, in every locomotive we sell. What a wonderful, wonderful idea. First time in the industry. And so they're going to install the E unit. Well, when I picked up this piece and took it up and looked at it, I said to myself, you know, this is not the usual Lionel. This section here was rough cut. It was cut by obviously some kind of electric tool probably, or hacksaw. But it was never finished. Everything else about Lionel engineering has a finish to it, a sophistication. We are proud of what we make it look good. And this piece, it certainly worked. You had the E-unit there, and it fitted, but it didn't feel right. So I didn't know whether I was looking at a very skillful home mechanic or what. A month or two later, my friend Warren Kennedy from the West Coast, who was photographing and studying his collection, which appears in the book, sent me a picture of his. He said, "Bruce, there's something peculiar about this engine. That E-unit is kind of crudely put in a crudely cut out section." I said, "Warren, maybe this was the factory's first effort." I'm still not convinced. Then a couple months later, Ken Morgan writes me and says, "Bruce, I have this strange looking E-unit in a motor. With 3, the likelihood that the factory did it is very high." Now, think back about that initial model where the pendulum reverse was put beside the side frame. Remember how I showed you earlier that Lionel initially, the picture, let's see if I can show you the picture here. Where's the picture? Bear with me, because I think I want to show you that picture again. And I have to put my glasses on to see it. Bear with me. Where is that? Up. Nope, not that one. You know, I showed you the picture, but I'm not here. This one? Yeah, here it is. I'm sorry to do that to you. Remember, initially, with the pendulum reverse, it fitted between the side frames and standard gauge. They showed a model in the catalog, which was never made, with the pendulum reverse between the side frames. And again, if you ever see it, buy it. It's a factory prototype. So here again, we're back to so they put the E-unit between the side frames. Okay, very interesting, the engineering idea, but they weren't happy with that. And the following year, they did this. They hung it on a bracket outside the side frame. And again, remember the pendulum unit. They hung it over the engine from the back. And so I see the engineers coming up with the same solution to the same kind of issue. So this was the last version of the Lionel 253, also the last version of the 254, where you have the triangular gear cover over a single large gear. You have the phenolic on the other side, brush plate, and you have the E-unit hanging on the end. In summary, from 1924 through 1933 or 34, Lionel Engineering Department continually changed and improved the motor. You've seen steps this evening. And again, the motor is the most important part of the locomotive. Motor quality determines consumer satisfaction. So this evening I have recounted how Lionel both improved its motor and met competitive challenges from Ives and Dorfan. Thank you very much for your attention.
I have 2 questions. The first one, the difference, you're talking about, you mentioned the E-units and the motors, but was the motor, let's see, American Flyer had the best reverse unit.
No, right.
American Flyer came out with it first. But was the Lionel
American Flyer had the first reverse?
excuse me, Ives had it. Okay. And Was the motor any better than the Lionel motor itself?
Oh, I'm going to pass on that question. There are advantages to both motors. And you and I would have to work up a set of criteria and hopefully agree upon them to say which was better. So I'm going to pass on that question.
Well, the second part of that is within the 9 motors that Lionel had, did they get stronger and stronger as they got to the 6, 7, 8, and 9? Or were they all the same power?
Well, motor performance is the result of the weight issue. How much weight is over the axle? How much power is available from the power supply? The number of windings. Again, I don't know how much the winding changed in what's called the field and the armature over this time period. There is a gentleman named Bob Hammond who's actually written some papers on this. He repairs motors, and if you have an O-gauge motor that needs repair, I highly recommend Mr. Hammond. So the answer to your question is Bob Hammond has it in this data, and I don't know whether Lionel changed the number of turns in the motors during this time period. Yes, sir.
Mr. Greenberg, in your price guide, like on this particular locomotive, you list the 13 years that it was produced, but I don't recall that there's any price variation based on all these different motors. Does that affect the value of it? Are some of them rarer or more valuable than others?
Very interesting question. The value of the items is largely what collectors are interested in. And collectors are primarily interested in the surface detail, the color of the locomotive. And particularly whether the color is easy to find or hard to find. And it's the nature of collectors that collectors value things that are hard to find. Each of you, when you think of your collection, have those pieces that are your special pieces that are hard to find, you rarely see elsewhere. So it's basically the physical appearance, particularly the paint color, and to a lesser extent the trim, that determines the value. And again, yeah, that would be my answer.
That's interesting, still true today, because the last time that Mike Wolf was here, he said the number one determinant of a piece of rolling stock is the color. But then later, it's both supply and demand. For true collectors, wouldn't it be, I was wondering to what extent in the early 30s you would have had much less production, shouldn't you, because of the depression. But the demand by collectors should have been the same later, 10 years later, right? Or 20 years later. So shouldn't 30s shouldn't those engines in the 30s be more valuable?
Well, what I think we think about collectors are generational. So first of all, what people collect is largely driven by their boyhood experiences and boyhood desire, except in the case of pre-war Lionel and pre-war American Flyer, there are very few people who were boys who had trains at that time are still active. So this is a special thing, this is acquired taste. So it's a special, different market. It's a different kind of market than the market for the desire of what you didn't have. As to color, I think as Mike is obviously speaking with great expertise as to selling new goods. I'm speaking here of what collectors are willing to pay, as we have been able to figure out. So the trains that appeal to people most are in part the rarity, but also there is a function of color and shape. So I'm going to basically say a little bit of this and a little bit of that. So for example, the 253 came in a wonderful peacock blue, one of my favorite colors. And my suspicion is that the peacock blue one, which may or may not be less common than the Mojave, the tan one, or the light green one, simply attracts more people. And so the price might be a little higher. But on the other hand, peacock blue is relatively common because it's sold well. Mojave's common. The rare ones, that first one I showed you in maroon is hard to find. It brings a premium. There's a gray one, it's very, very hard to find. It brings a super premium, and it's not very pretty. But for those people, this is the other part. There's a part of the collector world that says, I want only the most difficult pieces. I want a collection when people walk in, they know that I have the super dupers, the ones everyone else wants. And those are a small portion of the market, but they are people who have lots of resources, and they have driven up those prices for that ugly gray one to a ridiculously high price. So yes, color does matter, but it matters in a different kind of way.
Bruce, when you were doing the price guides in the early years, how did you gather the information for the different colors as to the value? And who were your resources? How do you determine which ones are a little more difficult, first starting when you didn't know about it?
Well, that's it was a real challenge. The answer is, I asked, quote, the old boys. I was a young kid, I asked the old boys, and some of the old boys were, oh, I'll tell you, Bruce, and others say, go away. And what I discovered, it's a great question about markets, recording prices in market. How do you reliably record prices, especially with the hundreds and hundreds of items? Well, what I discovered was I was able to entice, urge, please people to go through my list of the items in that particular book and give me their estimates. I gave them a definition of the estimate. Ready sale at a big train meet. Okay? Ready sale at a big train meet. And what I discovered with people who I'm most indebted, by the way, really indebted, there was a real correlation between reporters. Now, one fellow would be $5 higher or $10 higher than the other fellow, but they would go up and down the same way, which really intrigued me. It meant that there was a shared psychological space created by people walking through halls that wasn't done by anybody organizing it. It was simply human beings in their heads who are market people kind of remember things. So some of you in this room, I'm sure, are really market people and are really good on numbers. And you can walk into a hall and say, that's too much or that's too little. Others of you are not really that interested, and you buy what you like, or you buy this or buy that, but you're not numbers people. And the number people know who they are. And they are really critical to my work in reporting on markets. Yes, sir.
My question is that you described each type of motor as they improved it. Were there many, it seems to me that they kept changing the brush arrangement and then later the gearing. Were there other parts, I'm assuming, from the original version, the original type motor, that could be used throughout that period? I mean, they weren't redesigning the motor every time. There were a lot of parts you could use over and over again, the wheels, the axles.
Oh yeah, I'm sure I haven't studied the wheel bearings, but I suspect they changed the way they stamped out the wheel bearings. They may have changed the materials used in the wheel bearings. They may have changed how the wheel bearings were fastened into the side frames. We all know the wheels changed quite a bit. We know the wheels initially in this time period had spokes. They were made of a two-part, a zinc alloy casting for the spokes, and the tread then covered with a steel rim and steel side was pressed on. Later, about 31, they decided they wanted a disc wheel rather than a spoke wheel. In the late mid-30s, they changed the materials for the wheel. So yes, there are other things going on. I could take you down the tour of the coupler story, which is another wonderful story because other than motors, the coupler is the single most important part, and they make millions of them.
So what you're saying is, and this is what you started out to say, now it kind of brings it all together, is that the motor was so important to the satisfaction of the customer that Lionel really wasn't trying to save economies in transferring parts from model to model. Their concern was every time they came out with a new motor, they were lessening their repairs, hopefully improving the appeal, the reliability, all those things. So every type change was an improvement, and not so much thinking, well, we'll just get by with this. They were really trying engineering to make a better product.
Yeah, basically engineering has to set priorities. The managers set priorities, what's most important. There were engineers who wanted to go off in that direction. They would say, no, let's focus here. So yes, we can carry this analysis to other components and watch them change. And, but we can see why they had this particular focus. Yes? Am I answered the question? No?
You are. I guess my final question, I'm just trying to get the flavor for all this, and you're doing a great job explaining it. I guess, as I think back, from what I know, it must be that Mr. Cowan was just really aware of what he was doing, what his customers wanted, what his engineering people had to do. I mean, it sounds like to me that doctrine of let's make it better must have started with him. Is that possible?
I would say that in some organizations, the leadership defines how people approach the problem. If the leadership isn't clear as to what it's doing, the organization doesn't have that focus. But successful organizations have leaders who focus the organization on what they think are most important, and if they're right, the organization succeeds. Mr. Cowan, I'm a student of Mr. Cowan's work. I read his work. That's what those catalogs are. I study his products. He was a very impressive man.
You raised an interesting, they had a 6 or 7 year window for the boy. If the engine broke in the first year, you completely eliminated another 5 years worth of sales.
Yeah.
So
You're absolutely right. You're absolutely right.
Competition is driving it.
Yeah, you're absolutely right. I agree. And things how can I say? Oh, another related story. Peter, in his introduction, a very kind introduction, thank you, mentioned the first major product, the Lionel Service Manual. How many of you have seen the Lionel Service Manual? Okay. How many of you have seen an original Lionel Service Manual? Okay, good. It's a extremely unusual technical manual. There is no other manual like it in the toy world, and the other manuals that are similar are the automobile manuals, where the manufacturers invest very significant resources to show the service people how to fix them. And it's a glorious manual. We've produced a few pages each month from 1946 to 63 or 65. And it came from a man, he didn't do it, he told some people, I want a manual that shows our service people how to support our product. I want a manual that shows people how to make the fine-tuning adjustment so the product works better. He obviously gave that direction because it was expensive to do what he did. And we are all the great beneficiaries of that focus, that direction that he gave.
Who was it? I say, who was it?
Well,
You don't know who it was?
well, I don't know who he told to do that,
Yes.
but he obviously hired the right people who had the competency to carry out that manual, and it was probably, because it lasted a long time, it was a 20-year project, it may have had several directors.
So does when you talk about the different engines that Lionel made, do the motors for each of those engines follow basically the same progression as the progression when you talk about the 253?
Yes. They use the same motor with some modifications
Right.
from the bottom of the line to the top of the line. And so if you get a 1927 254, 252, you're going to find a motor, I hope, that I described here this evening.
Bruce, how about factory repairs? Say somebody sent in a 1924 253 that had a major failure, and instead of repairing it, they'd send something, a newer 253. Have you ever run across an outfit box where the locomotive plainly doesn't fit the box and the cars? Has that ever surfaced in your...
Yeah, yes.
Yeah.
In collector lore, it's a very important idea that the irregularities may be due to factory repairs. The collector lore has both, it's useful, but other times it misleads. I've tried to find documents of people who sent their train set to be repaired, and when it came back it had a different motor. I know of 2 cases, so I've written it down. Again, the factory is selling millions of units in the 50s a year. It's probably repairing 5,000 or 3,000. I'm just kind of make up some numbers. So that the proportion that actually get to the factory are relatively small. But yes, as part of the story and part of my challenge as a student of the sets and the outfits is in the box, is that what the factory put in the box? In fact,
The shell was the same. The outside was the same.
the motor, yeah, the
The shell of the engine, like
The 248 motor is the same as the 252 motor. The frame fits over the motor, and then the body fits over. So the variation is in the frame and the body.
Might have been just simpler just to send a different locomotive that was the same color, maybe.
Yeah, yeah. There's a lot.
Why spend the time to pull the motor out of the front?
that's what I did.
Well, in fact,
Call it the cost factor, just give him a new locomotive.
well, in
That's
fact,
what I did.
in fact, Brandy, in terms of the factory, they have a peak load problem. Between November and January, everyone wants their trains repaired. It's like the air conditioning problem and the roof repair problem, right? So my guess is they built up an inventory of motors, and they just swapped the motor and put it back in, rather than trying to fix that phosphor bronze strip. Gad, we'll save that till next July when we're less busy.
Throw it in the junk bin and give him another locomotive.
Yeah. Well,
That insulating material that would cause something...
phenolic. Phenolic.
Is that material that American Fire used to, when you sent the juice from the tender to the engine and plugged in?
It's different.
It's different.
Yeah.
And was it patented? They bought it from somebody? I assume they didn't develop it, or?
I believe it was a readily available product. Now, whether DuPont or some other major company owned a patent and produced it in quantity and enjoyed a special profit margin, I don't know. I'm sure we could find out very readily whether phenolic were patented and whether the patent was successfully defended.
Did anybody else use that in their engines?
Pardon?
Or did anybody else use that as an insulator?
I'm sure, yes, I'm sure it was widely used because it was such a wonderful material. Well, I'd like to thank you all very much for being, and I'll stay here until the last person departs and try to answer your questions. Again, thank you very much.
just have a little,
Hey, George, you're
there it
here.
is right there. Give you a quick here. That's right. A little appreciation, really appreciate you and Linda coming. And thank you for
George,
coming.
thank you very much. Again, I would appreciate, I'm honored by the chance to be here tonight. Thank you very much.
So Bruce has his books back here. If you want to buy one, see Bruce or his wife. And it's a Bible.
Bruce, what's the price of the book?
$100. Oh, let me make one comment. Peter raised the question implicitly. The first book is called 1915-1928, but it actually contains trains that run into 35 and 36. What was I doing or trying to think about? The problem here is I want to carry a line through its story, but I also needed to divide the book because obviously I have 400 pages there. I can't have an 800 or 1,000 page book. It's ridiculous. So I chose 28 as a cutoff for new products. That meant that the O-gauge steamers, the 260 series, end up in the next book. But I didn't want to leave out any of my favorite 253s, and you'll find a 1936 253 in that book. So that's what the book actually is. I gave a title, but then I have to explain what I really meant.
Thank you, people. Thank you very much. Have a safe trip back.